Yeah, the Earth is getting bombarded with flares, and I thought I'd take a look again at the winds here on Earth, and I think that's really an interesting pattern. It's coming from America, going over Europe, and all over Russia. To Kamchatka. This is Kamchatka. No, this is Kamchatka. Sorry. That's Japan. The lower one is Japan. This is Kamchatka. That island. So, and then it just turns northwards. And it's a funny kind of polar vortex. Yeah, I want to show you what we are looking at. That's the highest of the winds what you can get here on null school. Jet streams. And this polar vortex, besides that, now we'll show this other thing later, but now I put particulates away because they somehow disturb the view. Check this out. This is going over the North Pole. It should be more like that. It should go around the North Pole and not over it. And that part of the scene is also very, very interesting to me. Let me show you something. Let's zoom a bit out. Just in order to refresh your memory. That's Kamchatka, that's Russia, Alaska, Canada, Greenland, and I'm somewhere over here. So let's go over to Pollshiftnews.com. Give him some props. Gene and his observatory. It's, as far as I know, the only place where you have real-time tracking of the magnetic North Pole. It's actually not. Where are the live data? Yeah, let's go with that first one. So, this crack here, I don't remember the name. That's an important landmark. That's the Laptev Sea. Somewhere here is the Laptev Seamount. Obviously there's a volcano too, which is not a surprise. It's just not marked anywhere. So, the magnetic North Pole at the moment is somewhere here, I guess. It's getting closer to the 40 degrees mark, which is really important because it's entering then the weaker field lines and things may happen much quicker than before. So, let's go over to Google Earth because I want to show you something. We need grid lines and the globe, otherwise it's really hard to show you. Map style, clean grid lines. So that's the crack what I was talking before. And it comes from all the way here. Somewhere here we have La Palma, Iceland. And that's the Laptev seamount, I guess. I'm not really sure. But now let's put the lines off. Just that you see that we are really north. We had actually an earthquake that was even more north, which you couldn't see really on the map because it stopped. Volcano discovery application, it stopped somewhere here, but the quake was somewhere up here, so really in the north. Okay. Our jet streams at the moment of the polar vortex is somewhat blowing like that. Or is it more to the right or to the... Let's have a look. Here we are. What are we looking at? That's Greenland. No. Now I remember. So, at the moment, the winds go like that. They follow exactly this crack where we have the Laptev seamount and some volcano probably too. But the line continues, even though there's a little bit of gap in it, but I just think it's because of the Google Earth quality. They just don't want to show. Or it could go like that too. So the winds are exactly on that line. And somehow I think the winds, they're getting locked into somehow places through interactions between Earth and the atmosphere. Imagine that they're the crack, which would, how to put it, emit electromagnetic energy from the ground up, and there's the atmosphere with the winds, and they will somehow interact. If you would watch it from the front, here is the energy flowing in the ground. So the winds probably, or the airstreams, get attracted to that. If you charge whatever gas 1% with electricity, it's plasma, it will act like plasma. So I find this really interesting, that the winds are exactly on that thing. Does this indicate that our magnetosphere is really so weak that the wind patterns, they got really locked into those places? Is this just a thing which will pass? Tomorrow it will look completely different? I don't know. I just noticed that coincidence. And since we have quite much stuff coming from the sun, it's not here yet. We had flares, probably there's more coming. Flares also affect the weather, but I think the CMEs, or the big CME, like it will just increase the amount of energy which is flowing in those subsurface energy circuit streams which are crossing the whole globe. they are really easily visible. For example, the Ring of Fire. And we go probably over to the places everybody's talking about. This one goes here, and as you can see, it's spreading towards both sides. Not exactly equally, but it does. And you can just follow those, because you can see, like, you know, really see it. Coming here, coming there, and then it takes a turn to there. Wrong button. And it goes into the Alps too. And it goes here from the south to the north, and a little bit to the right and there. And then we have volcanoes, we have volcanoes, we have volcanoes. All kind of geothermal activity, which is actually much bigger. It goes like something like that. And we have volcanoes in Spain too. We have volcanoes in Italy. Wherever you look, there's volcanoes all over the place. In the middle of the sea, Mediterranean. And we have, of course, a lot of volcanoes in Turkey and Middle East and wherever you would look. Yeah. Dragon teeth. Jet streams are locked on the, what is it? Like on the cross. On the axis, on the actual North Pole. Geometrical North Pole, probably. Which, actually, I forgot to tell you one thing. Which somehow makes that place really interesting. Maybe I have to check this region out. Is there something from interest? Because I guess there's a reason why it's there. Like this. I mean, the sedimentary composition of the rock and all these kind of things. Is there anything interesting? How does it look? Should we? Let's leave Iran. And go to Russia. Craters, peatlands. What else you would expect from a region which is during certain times or periods really much affected by electromagnetics. From galactical scale. Yeah, this looks interesting. Material fused together. I don't think that this was a volcano doing that, because there's too much of repetitive patterns. Just somehow doesn't make any sense that some random flow of some random material somewhere like would create this kind of mount. Really? And there's this kind of seam between different kinds of materials. Yeah, I bet there you will find something interesting if you would dig. Or just walk around, pick stuff up from the ground. Like all the pieces I collected, they are just like, they were loose. I didn't use any tools to get them. No drilling or whatever. Chiseling. Nothing. Picking stuff just up. Yeah, it sucks that you can't somehow check the height of them. If you have like Google Earth on a computer, you can. You can always check the height of them. Yeah, there's something probably from interest, but for now I haven't found anything. Yeah, I leave it here. Thanks. Bye. Jet streams, North Pole. Interesting.